Hey guys, it's Eddie the Magic Monk. In the last lesson on normal distribution, hopefully you have learned a little bit about z-scores, and today we're going to teach you guys how to use z-scores. So we're going to start off with a very simple normal distribution example. So the example is that we have some students at a school and they're all 17-year-olds and their heights are normally distributed, which means that we can draw a bell-shaped curve with the mean of 180 centimeters. So most people will be around that height, and a standard deviation of 5 centimeters. So let's just show you what that means. So if I draw a normal distribution curve, I'm going to have something that looks like that, and the highest point, which is in the middle, is going to be 180 centimeters, and the further away we go, the less chance of it occurring. So 180, around that, has the highest probability, and then 185 a bit less, 190 even less, and 175, 170, and so on. So it says, what is the probability that the height of a randomly selected male is between 180 and 187 centimeters? So that would be between 180 and 187, which is somewhere around here. We want to find this area under the curve, okay? Because the area underneath a bell curve, this area, is the probability. The probability of a randomly selected person is between 180 and 187. So if we can somehow find this area, then we can find out the probability. But how do we find this area? Well, if we have a look at this table, this table is called the standard normal table, standard normal curve. And it tells you the probability between the mean and a certain z-score. If you have no idea what z-score is, please have a look at my previous probability lesson. But basically, a z-score tells you how far away from the mean you are. And the point of having a z-score is basically so that we can use this table to find out the probability of getting a number between the mean and the z-score. So if we have a look at our formula for finding the z-score, the formula is z is equal to x minus the mean divided by the standard deviation. So the x value that we want right now is 187, because we already know the z-score of 180 is going to be 0, because it is the mean. The mean has a z-score of 0. So if I have another row called z-score, the mean would match up to 0. 185 would match up to 1, because it says standard deviation is 5 centimeters. So 1 standard deviation, which is 1 z-score. Z-score is basically how many standard deviations is it from the mean. So 5 centimeters is 180. 180 plus 5 is 185. So 185 is 1 z-score, has a z-score of 1. Okay, so what is the z-score for 187? Well, let's substitute that into x. So we have 187 minus the mean, which is 180, divided by the standard deviation, which is 5. So let's put that into your calculator and you should get 1.4. So all you have to do to find this probability is to go back to our table and look for a z-score of 1.4, which is here. Now, luckily, we don't have a number after the 4, but let's say that we did. If you have 1.41, 1.42, for example, you would move to the right until you get to that number. So because we have 1.40, this is the number that we choose, and it's simply 0.4192. So we say that the probability of the z-score between 0 and 1.4 is simply what was it again? 0.4192. That is the probability of getting a z-score between 0 and 1.4, or between 180 and 187. So you can write it like this: 180 to 187 is 0.4192. So you might say, okay, what if I want the probability of a height that is bigger than a certain number? So let's give you guys the question. Find the probability of a randomly selected male is taller than 189.5 centimeters. So I have deliberately chosen a number with a decimal point so that we will get a more complicated z-score. But if we have a look, we have a normal distribution curve. Oops, accidentally pressed a button on my stylus, sorry about that. Very badly drawn curve with 180 in the middle, and 189.5 is somewhere here, and we want to find out the probability of a randomly selected student being bigger than 189.5. So we need this area under the curve. But if we have a look at the table, it only tells us the probability of the student being between the mean and a certain z-score. So we're basically going to find this probability that I'm going to highlight in green again. So we're going to find this probability, and then we're simply going to go 0.5 minus this probability. Why is that? Because this whole area under the curve, has a probability of 1, because that is 100% of the population, so the probability is 1. So what is half of that? Half of that is 0.5. So if I did 0.5 minus the aqua color, then I will get the pink section, the area of the pink section. So how do we get the area of this section? Well, we need to firstly find the z-score of 189.5. So z is equal to x minus the mean divided by the standard deviation, which is 189.5 minus 180 divided by the standard deviation, which is 5, as I have previously discussed. And now it's 9.5 divided by 5, which is 1.9. Now, again, this number is not very complicated, so I'm going to make it slightly more complicated. So instead of 189.5, I'm going to make it 189.532. 532, so it's 532 divided by 5, which is 1.9064. Now, this is probably too complicated now. I should have, because our table only works up to 3 decimal places. So I have 4 decimal places. So the only way I can do it is if I round it to 3 decimal places. 1.906. 3dp. Okay, so let's say that I now want this probability. So what I do is I then look up in my table 1.906. So where is that number? So I have 1.9 on the left. I have 0 again. 1.90, but I have a 6. So how do I use this column? Well, let's go to 1.906. Let's go to this column and let's get that number. So what we do is we add this number to the last digit, of this probability. So it's 4713. So what I'm going to do is I'm going to write it out. The probability of X being between 180 and 189.532 is actually I should probably use Z for now. The probability of Z is between 0 and 1.906, because the the Z score of 180 is currently 0, and the Z score of 189.532 is 1.906. These are the X scores at the top and the Z scores below them. So we want to find the Z score between 0 and 1.906. What is the probability? So let's get that number out again. So what was it? It's 0.4713. Now we're going to add the number in the difference column to the last few digits. So to the last digit if it's just one number, but if it's got 2 numbers, then you would add it to the last 2 digits. Okay, so we just added to the last digit, so it's add a 4. So we're going to plus 0.0004. So we only add it to the last digit, so it's 0.4717. So that is the green probability. But remember, what we're actually looking for is this probability. So we're going to go 0.5, which is this whole section here. That's 0.5. So 0.5 minus 0.4717. And the answer is 0.0283. So let's write that down. Probability of the Z score being bigger than, so Z score is bigger than 1.906, and the answer is 0.0283, which is very small, which makes sense because this is a very small area to the right hand side. Okay, so that is how you find the probability of a randomly selected male is taller than a certain number. What if you want a randomly selected male to be between two numbers and the number on the left is not the mean. Okay, so let's just do that one quickly. What if we want the probability of x being between 180 to 180 is the mean. Okay, let's just change that to 170 to 185. Okay, so what you do is you got to convert these x scores to z scores. Okay, so if you use the formula to convert from x to z, you will see that an x of 170 would have a z score of, so you would go 170 minus the mean is 180 divided by 5 is the standard deviation, so that's the z score. So the z score will be -2 as -10 divided by 5, which is -2. So let's write that down. And then the same thing happening here. 185 minus 180 is 5 divided by 5 is 1. Okay, -2 and 1. So how do I now figure this out? Well, if you draw a normal table again, you will have a z score of 0 in the middle. A z score of 1 would be somewhere on the right. So if we simply find this area first, so that area, if we go to a z score of 1, is 3413. So let's write that probability down. This probability is 0.3413. And then we want a z score of -2. How would we find this area? Well, if you guys can see that because the normal distribution is a mirror image of the right hand side, this probability is going to be the same as if I draw a positive 2, this area is going to be the same as this area. Both of these are going to be the same size. So that's why I can simply look up probability when z is equal to 2. I can simply use this number, 4772. 0.4772. Okay, so now let's add that 0.4772 plus 0.3413. Let's add them together. And the answer is 0.8185. Okay, thanks for watching, guys. See you next time.